All right, now that we've become familiar with how to kind of solve logs, if they have logs on both sides, or if it just has log on one side, we rewrite it as an exponential. We are going to move into word problems. So I have a word problem over here, and it reads, the half-life of radium is 1,609 years. If 20 grams is present now, how many years will it take to have 15 grams left? So basically, we're starting at 20 grams. We're going to go down to, we're waiting so much. How long do we have to wait till we get to 15 grams of radium? Now, it tells us the half-life. So let's kind of dive into this to solve it, because this is actually a two-step process. All right, so this is all the information it gives us, but it does tell us that my time for my half-life is 1,609 years. And we need to figure out how many years is it going to take to go from 20 grams to 15 grams. So if I notice, I've written the formula A equals A naught E to the power of KT. This is the formula we're going to use as exponential growth or decay. If my K is greater than 0, then it is growth. If K is less than 0, it is going to be decay. So here we should expect a negative, because we're going from a larger number to a smaller number, so it's going to decay. So we're going to expect my K to be a negative number, but I don't know what it is. So we need to find it. So we're going to just kind of think about this. I'm going to say, well, half-life, half-life, well, half is 1/2. Half of 1/2 of 1. So if I start with 1, I want half of it. And I have E to my K, which I don't know, but hey, I know the time of the half-life, which is 1,609 K. So now I just simply solve. I don't really need to write this 1 right here. I just need to solve this equation. The way to solve this equation, E, I need to ln both sides, because ln of E is 1. So I'm going to ln 1/2 equals ln of E to 1,609 K. Well, this exponent can come in front. I can expand this out. I've got ln of 1 minus ln of 2 equals 1,609 K times ln of E. Well, this is 1, this is 0, and I got negative ln of 2 equals 1,609 K. I can divide by the 1,609, and I get K equals negative ln of 2 over 1,609. So now I found K, which is a negative number, because I have a positive, ln of 2 is a positive number, 1,609 is positive, and the negative, that's the negative that I would expect. Going from a larger number to a smaller number, my K has got to be less than 0. In fact, this K is less than, so this is a decay model, not a growth model. All right, now that we have our K, we have an A naught and we have an A. We don't need this T sub n anymore, because we use that to find K. Now I need to find how much time is it actually going to take to go from 20 grams to 15 grams of radium. So I'm just going to plug everything in that I know into my growth or decay formula. Well, I know A is 15. This is going to equal 20 is my A naught. E, well, I have my K, which is negative ln of 2 over 1,609. And then I have T. I just need to solve for T. Well, to do that, I need to get E by itself, and then we're going to do that same trick. We're going to ln both sides. So I'm going to divide by 20 and simplify the fraction, so they both have a 5 in common. So I'm going to have 3/4 equals E to the negative ln of 2 over 1,609 T. We ln both sides. I get ln of 3 over 4 equals, well, this just simply becomes a negative ln of 2 over 1,609 T. Whenever I have a fraction, I multiply both sides by the reciprocal, and I want to get 1,609. I want to put the negative right there. ln of 3 over 4 divided by ln of 2 equals T. All right, well, that's the exact time, except I've never expressed time in terms of ln or that. I always express it in like just years, maybe a year to a decimal, or I can convert the decimal to months if I really wanted to. So all you do is take a calculator, throw this in here and get an approximate number. So T is going to be approximately 667.8 years. So it's going to take about 667.8 years to go from 20 grams of radium to 15 grams of radium. Kind of a nifty little thing to know. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.